which is 1 over x. Therefore, the left-hand side will be 1 over c. The right-hand side, the denominator has 3. Natural log 4 is simply natural log 4. But how much is natural log 1? 0. Natural log 1 is 0. That's why I will not even put it in. All I have to do, this is a proportion. In a proportion, you can do this. C equals 3 over natural log 4. I have to show that this is indeed in the interval 1 comma 4. So that's a little trick, tiny trick. So with proportions. So if you have a over b equals c over d, you can do both at the same time. So I need to show that 3 divided by natural log 4 fits in the interval 1 comma 4. It does. I really didn't have to. It's guaranteed, but just to make sure. So indeed, this is the C guaranteed by the mean value theorem. Any questions? Any questions? Any questions? Ricky, go ahead. Anything? Any questions? Any questions on Rolle's theorem or mean value theorem? Yes, Ricky, go ahead.
So F prime of C, we have to find F prime of X there.
Yes, and then, well, to be honest, you can use F prime of X equals, and you can find X and say that that's your value. You don't have to use C at all. But we like to use C as the constant that we are looking for in the interval 1 comma 4. But you can write F prime of X equals, and then solve for X. And at the end say, this is my C. That's fine too. No error there at all. Any questions? Is that okay? Good. So now the next 4-3, 4-4, and 4-5, they all deal with the same thing. So 4.3 through 4.5. We're going to learn how to graph functions using f prime, f double prime, and limits. Well, this is not the title of 4.3 through 4.5. I just like to put them together because they are together. 4.6, I will not cover, but I encourage you to look at it. It's graphing with using calculators and using computers and other things. I can show you a few different one software we have here, but only if we have time. If we have time, with pleasure. So 4.6 I will not cover. 4.7, just to give you an idea what's ahead. 4.7, optimization. Optimization is a big piece of math, like algebra is, geometry is, and trig, and so on and so forth. Optimization is a huge branch in which we are trying to find max-min of functions. And that would be 4.7. And the last section before we schedule test 3 is Newton's method, which is extremely interesting in my opinion. You will be able to solve any equation on this planet by hand. Any equation that you can think of, you will be able to solve it. Yes, we will have to do some arithmetic with a calculator, but you will be able to solve with any accuracy you want. 10-digit accuracy, 15-digit accuracy, you choose it. Okay? It's going to be very interesting. And that will be the end of this chapter. So what is this all about? Number one, I like to list an important item here. What do we know from the first derivative about a function? What does it give us? It gives us critical numbers. It gives us potentially max min. What else does it give us? Increasing, decreasing intervals. So why would we ever want to study a derivative of a function? At least for these three reasons, right? Number one, to find the critical numbers. Number two, those critical numbers, some of them, or maybe all, it depends on the function, may turn into max min. What else we learned from the first derivative? The increasing and decreasing intervals. If the first derivative is positive, then I know the function is increasing. If the first derivative is negative, then I know the function is decreasing. So this is one thing that we will always have to look at when we graph a function. Number two, what do we learn from the second derivative? We haven't gotten there, but I'm just going to give you a preview. From the second derivative, we will learn two things. Concavity. Concavity, meaning if the function opens upward or downward. This is what we are going to learn from the second derivative. What else are we going to learn? Inflection points, if any. Function doesn't have to have inflection points. But if it does, we will learn about them from the second derivative. What does this mean? Just a quick preview. Remember we graphed x cubed. And here's how we graphed x cubed. Opening downward. But then all of a sudden at this point, we show that it was opening upward. At this point, the function has an inflection point. It changes concavity from opening downward to opening upward. This particular point, just this, the origin, it's an inflection point, point of inflection. Okay, and number three, since I mentioned the first derivative, the second derivative, and limits, what do we learn from limits? We will learn end behavior. What happens at infinities? End behavior. And what else we will learn with using limits? The behavior left and right of a point. So behavior left, right of a point. Of an x value, I should say better. Left, right of an x value. This is what we learned from the first, the second, and limits. Okay, on page 299, let's start with the function and go through all these and talk about each and every item. Let's say, I can let you choose if you'd like. Is that me again? Disregarded, I'm sorry. Okay, so let's start with, let's say 35. Of course, everything happens one day. Yeah, it's one of those days. 2 plus 2x squared minus x to the fourth. This is problem 35 on page 299. Two plus 2x squared minus x to the fourth, and we are asked to graph this function. Now, here's a list of items that we have to go through. I don't like the way the book presents this topic. Let me show you. So they go through A, B, C through H, and then all of a sudden they come up with a graph. They don't summarize the information anywhere. So the same thing here. Problem 5. Blah, 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 blah. Here's the graph. But they don't summarize the information. You have to look everywhere to see where they come up with this. So we're going to use a table, and I strongly recommend it to you too. So here's the table that we will use. X, of course, is the variable in the problem. F prime, the function in the middle, and the second derivative follows. Now you may ask, why don't you put it in order, like f of x first and f prime, and then f double prime? For several reasons. Sometimes this would be too difficult to worry about. It will take too long to find it. So I may not need it. Writing the first derivative first and then the function will be, I think it will give us a better picture of these two rows. Like we did a few minutes ago with, if you remember, with study of the function on a closed interval. I think once we see the derivative here and the function below, it's easier to connect these two rows. If you decide to change the order and you understand it and you're happy with it, I'm happy with it. It's up to you. Okay. So once we finish filling up this table, then you actually went through all these steps. I'm going to mention all these steps to you. But here, there is no need to list them. It's the best thing is once we find something, we put it in the table right away. So we don't miss anything and we don't forget anything. Ready? So of course, we have to start with the domain. I have to have something here. What is the domain of this function? What type is it? It's a polynomial, and then the domain? Negative infinity to positive infinity. Awesome. Very good. Now, what is the degree of this polynomial function?
4.
Indeed, degree 4. How many x-intercepts should I find? 4. They may not all be real. Some of them may be the same. I don't care. But in the back of my mind, I have to say I expect 4 solutions to the equation f of x equals 0, or 4 x-intercepts, or 4 zeros. All these mean the same thing. 4 solutions of the equation f of x equals 0, or 4 x-intercepts, or 4 zeros. These are used interchangeably. They all mean the same thing. Okay. So I have negative x to the 4th plus 2x squared plus 2 equals 0. I multiply both sides by negative 1, x to the 4th minus 2x squared minus 2 equals 0. So I'm finding x-intercepts. Now, this situation is not as easy as it seems to solve this, right? Because it's degree 4. One possibility would be to change the variable. Denote x squared by t, and this will be t squared. And then solve that way. Another option is to solve it and find the zeros with the graphing calculator. Let's do that. Let's put the function in. We're not graphing it. We're just trying to find the solutions quickly. Because the purpose of this is not to test ourselves in solving 4th degree equations, but we need to find the x-intercepts quickly. So let's put the function in. Let's put the function as is. It doesn't matter really. Whatever I put, I determine the 0 is the same thing. So x to the 4th minus 2x squared. I changed the equation by multiplying both sides by negative 1. It doesn't matter. As long as I'm consistent, I can solve this or the other one, same thing. And let's go to second and calc. And we are finding the 0. Now, if you put a second function, like y equals 0, which is the x-axis, then you can use the intercept. But there is no need to do that. So let's find the zeros of this function. Choose 2. It's going to graph, but we don't rely on this graph. We are going to discover everything on our own. It appears that out of 4 solutions, how many are real?
2.
Only 2. The other 1 are imaginary. So in order to determine this solution, I see this is -2, -1. I'm going to tell the calculator to find the 0 between left bound -2, right bound -1, and the same thing on the other side. We already know that the function is symmetric, but let's say we don't know it at this point. Any questions, Braden? Are you okay?
Yeah.
Ron, are you okay?
My calculator's saying error. I don't know what.
Let's see what you put in. Because first of all, you have a plot, and you have to remove the plot. So now you're gonna. So now you have second and calc, and you turn it 0, and you want standard 12. Yeah, if for some reason if it has a plot in stats, it's not gonna graph it for you. Is that okay? Good. So between -2 and -1, and -1. And I found the solution. I don't want to guess. Enter again. Left bound, -2. Right bound, -1. Good. So
when I did it, I just moved my cursor to the left side.
yeah, I can drag the cursor, but why would did I put something else? Let me check again. So between -2, left bound, and -1. And I'm looking for the 0. I don't want to guess.
The calculator's off today.
But we see the x-intercept, right? We see the 0.
Yes.
It's there.
It is there.
It's between 2 and -2 and -1.
Right. Let me try this. The zoom 6. Maybe it's not standard or something. It refuses to graph now. So you give me the solution. -1.65,
Yeah.
and the other one should be 1.65.
Yes.
It has to be. The function is it's even. Very good. That's fine. I cannot make the system work, so thank you very much. So 0 in the middle. Give me the y-intercept also.
It's
Very good. And you said -1.65. Does anyone else agree with 1.65 and -1.65? Anyone else? Do we get the same thing? Ashley, did you get that, or does it work? Because I was not able to. It's one of those days. Nothing works. It doesn't do anything. It's frozen.
oh, press enter.
Okay, I did.
There.
Good. Let's try one more time.
Yeah.
I don't want to waste your time. I don't want to waste your time. So if you have the solution for me, that's fine. Left bound one more time, -2. Right, -1. Please.
It's just
Calculators.
it's process.
Yeah, it may be processing. Very good. Good. So we have the y-intercept. We have the x-intercept. The only thing that we need is the limits. Left and right, or for the end behavior. Ready? So limit from 2 plus 2x squared minus x to the 4th as x approaches infinity. and limit from 2 plus 2x squared minus x to the fourth when x approaches negative infinity. And we know how to handle this. We will be looking, since it's polynomial, which of these three terms is the most powerful one at infinities? X to the fourth. So when x approaches infinity, where does this term go? Always remember it has a sign.
Negative infinity.
Okay,
Positive infinity.
very good. So no matter what I plug in here, this will always be positive, and the sign will always be negative. Clear? So the answer is negative infinity in both cases.
Even if there's a negative out in front.
But when I plug in negative to the fourth, I get positive with minus in front. In x to the fourth, no matter what I plug in, I will always get a positive number. I go back to the table. Is everyone with me? Negative infinity, negative infinity, both sides. There is nothing else I can find about the function from the function itself. Done. Where do I go now? To f prime. Excellent. Well done. So let's continue with f prime. F prime, can anyone give us f prime?
Negative positive 4x.
Cubed, negative 4x cubed, plus 4x. When we solve the equation, I can solve either this or this. But when I define the derivative, I am stuck with the function. I can't make any changes. Good. So now I determine what? The critical numbers. So does this function have critical numbers coming from f prime being undefined? No, it's a polynomial function. So the only possibility is with f prime being 0. Negative 4x cubed plus 4x equals 0. Now I will definitely divide both sides by negative 4. And I have x cubed minus x equals 0. How many solutions do I have to find here?
3.
Yes, because the degree is 3. Awesome. How do I proceed? I will factor out x, and then I have x squared minus 1, and I will factor x plus 1, x minus 1, and indeed we get 3 possibilities. And what are they?
1, negative 1, 0.
Very good. X equals 0, x equals 1, x equals negative 1. Back to the table. Let's put those in. 0, negative 1, 1. Careful how you insert them. I may have to reconstruct the table if it gets too crowded and there's not enough room. I may have to rewrite it or reconstruct it. So now I need to study the sign of the derivative here, 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 and here. Ready? So this is a derivative. Let's put it in the graphing calculator. Y equals, assuming that it cooperates. Maybe. Let's put the derivative in the graphing calculator. So we got negative 4 x cubed and then plus 4x. Correct?
Yeah.
Plus 4x. Good. Let's plug in. We want a number to the left of negative 1. Okay, negative 2. We want a number between negative 1 and 0. Negative 0.5. We want a number on the other side, 0.5. And we want a number like 10 on the other side of 1. I copied just the signs. I don't care about those numbers. So it's positive, negative, positive, negative. Positive, negative, positive, negative. I need to determine the function value at negative 1 and the function value at 1. Can anyone go back to the function and tell us, since they will be the same, the function is even. So 2 plus 2 is 4. 4 minus 1 is 3. At this point, we're trying to make these two rows work well together. I don't know yet. That's where I catch my mistakes. So let's give it a shot. From negative infinity to 0, what does the function do? I know I only have 3 minutes left. We may not be able to finish graphing it today. Is that supported by the sign of the first derivative? From 0 to 3, is that supported by the sign? Good. From 3 to 2, is that supported by the sign of the first derivative? From 2 to 3, is that supported? From 3 to 0, is that supported? And from 0 to negative infinity. Good. It appears that everything we established or we discovered so far is fine. Okay, let's find the second derivative, and then if we have time, we'll finish it, but if not, we'll stop. So the second derivative is negative 12x squared plus 4. Before we do that, I just want to come back to the table for 1 second. So let's analyze this point, negative 1 comma 3. The derivative is 0 or undefined, right? But it's 0 in this case. And the function is increasing and then decreasing. What type of point is negative 1 comma 3? Local max, awesome. Let's look at 0 comma 2. The function, the derivative is negative, and then it's 0, and then it's positive. What type of point is 0 comma 2? Local min. Finally, 1 comma 3. The derivative is positive, 0, and then negative. What type of point is 1 comma 3? Local max. Very good. Okay, 1 minute. Let's just determine, set the second derivative equal to 0. And we get negative 12x squared plus 4 equals 0. So x squared equals 1/3. We move forward, we divide by 12. So then x equals plus or minus the square root of 1/3. We will have to continue this after